In this lesson, we want to talk about when it's appropriate to use GCF and LCM to solve a problem. When you're looking for the GCF, you should be dividing more than one thing into the largest possible equal groups. LCM is appropriate to use when you are repeating more than one thing over and over again and you want to know when the events will happen at the same time. I would suggest writing both of these down before you move on. For examples of when to use greatest common factor and least common multiple, we're going to use the website www.ixl.com for our examples. This one says, Bella's Blossoms sells roses in groups of 18. Across town, Kurt's Blossoms sells roses in groups of 12. If a customer wants to buy the same number of roses from both vendors, what's the smallest number of roses the customer will have to buy from each vendor? You need to ask yourself, are you going to have to take the numbers and divide them into equal groups, or are you going to purchase the roses over and over again until you get the same amount from each vendor? The answer is you would have to purchase groups of 18 over and over again and groups of 12 over and over again until you ended up with the same amount of roses from each vendor. This is the least common multiple. Another hint that it's least common multiple is that it's asking you for the smallest number of roses the customer will have to buy from each vendor. I will quickly find the least common multiple by using the prime factorization method. Let's find the prime factorization of 12 quickly using the ladder method. 12 equals 2 times 2 times 3. And the prime factorization of 18. 18 equals 2 times 3 times 3. To find the least common multiple, we first look for the factors that they have in common. They both have a 2 and they both have a 3. And then we finish by multiplying all the numbers that are left over. So we need to multiply the 2 and the 3 that are left over. When I multiply 2 times 3 times 2 times 3, that equals 36. That tells me that they would need to buy 36 roses from each vendor before they could have the same amount. Here's our next example. Albert is making a scrapbook using 18 photos and 12 newspaper clippings. He wants all the pages to be set up in the same way, with the same combination of photos and newspaper clippings on every page. He also wants to make sure that no items are left over. What is the greatest number of scrapbook pages Albert can create? We need to think, is Albert trying to divide numbers up evenly into equal groups? Or is Albert repeating the same thing over and over until he can get numbers to match? In this problem, if you think about it, Albert is dividing his photos and newspaper clippings up into separate pages, and he wants the same amount on every page with nothing left over. This tells us we're looking for the greatest common factor. The other hint is in the problem, it's asking for the greatest number of scrapbook pages that Albert can create. Let's quickly find the greatest common factor using our prime factorization method. We want to find the prime factorization of each number. The prime factorization of 18 is 2 times 3 times 3. The prime factorization of 12 is 2 times 2 times 3. To find the GCF, we look for only the factors that they have in common. They both have a 2 and they both have a 3. So 2 times 3 equals 6. That tells us that the greatest number of scrapbook pages Albert can create is 6 pages. If you would like to practice more examples, I would suggest going to www.ixl.com, clicking on the 6th grade level, and going down to skill N9, which is greatest common factor, least common multiple word problems.